In this lecture, we will discuss the const cast operator, which is used to cast away the const and volatile qualifiers when casting from a variable to a pointer or a reference. So this can be useful in quite a few instances. It is useful when you need to pass to a function that does not accept a pointer to const. So if the function has a formal parameter of type pointer to int, for example, and you have a pointer to an integer constant, then you can cast away the const before you pass in that pointer to the function, because otherwise you will get an error. Also, if you must, you can modify a non-const member in a const member function. So that is a trick that you can do. Of course, I do not recommend modifying the state of the object in a const function, but there is a trick that you can do that I will show you later on in the lecture using this const cast. Now, modifying a variable that was declared as const may produce undefined behavior, but it is acceptable to modify a variable that is not declared as const. That is, of course, if you have a pointer and you dereference that, you do not want to modify the variable that was declared as const, that is, that the pointer is pointing at, because that may produce undefined behavior. We will see some examples on this. And the syntax is basically the same as the other operators. You have the cast operator name, so in this case, const cast. You pass in the type ID that you want to pass to, so the type that you want to pass to, followed by the expression in parentheses. For this example, let's say we have some variable x, a constant integer, which is initialized to 33. Now let's say we want to use const cast to cast that const away, and we want to assign the result to some other integer y, for example. So for the type argument, we have type int, and then we pass in x for the argument. Now we will get a red squiggly with the type argument. So if we hover over that, we get the type in a const cast must be a pointer or a reference. So we cannot cast these fundamental types. We have to cast to a pointer or reference type argument. Cannot cast from const int to int. Alright, so I'll comment that out. We will get an error with that. We can also have a pointer to an integer. Tells us name ptr, and then we can use const cast. In this case, casting to type of pointer to int, and we get the address of x here. Then we can do cout, and I will dereference that pointer. And so we should get that value 33 printed out now. Build and run, and we get 33 as we may expect. However, one issue that you can run into is that you can try and reference that and then assign to that. So 47. This is going to give you undefined behavior. So build and run. At this point, you may get the results that you may expect, and then you may assume that that works fine. So we get 47. But if we change that output to x, build and run, we actually get 33 now. So where is 47 and where is the 33 then, right? Because both of those refer to the same value, which is stored in x. So again, with this, you can get undefined behavior, and you should avoid attempting to modify a const variable by dereferencing a pointer that points to that. In this example, our variable x is not const. It is still initialized to 33. Next, I have a pointer which I named cptr, that is a pointer to an integer constant. Use the address of x, store that address in here. And then we have another pointer here, which is simply named pointer, ptr, which is a pointer to int. So now we can use const cast. For the type argument, I pass in pointer to int, and then we pass in that pointer cptr, which is a pointer to an integer constant. Now, if we dereference and we assign 47 to that, that is ptr, because again, that is not const. If you do cptr here, then of course we will get an error, because that has to be a modifiable L value. So we do ptr, and then we dereference that to print it out again. If we build and run, when we dereference that pointer, we get 47. But in this case, if we simply print out x like this, build and run, then we should also get that modification, as you can see. So that is more expected results. And that is because the variable x is not const. So this here is fine. If we have a pointer to an integer constant that stores the address of x, then we can eventually do a const cast. Okay, and instead have a pointer to int, and then we can use that pointer again to write to that value that the pointer points at. For this demonstration, I've modified the previous example slightly to include this display function, which has a formal parameter, has a pointer to an integer, and it's going to, in the body, it's going to print that out. So we do cout and we dereference that parameter. Then in the main function, we have this x integer again, which I initialized to 33. Then I have a pointer to an integer constant, which I named cptr, and we assign to that the address of the x variable. Alright, so the same stuff that we've done before, we also have a pointer to an integer, and we use const to cast to a pointer to integer, and we pass in that pointer to integer constant, cptr. Now if we invoke the display function, we pass in that cptr. If we try to build this, we will get this error here, cannot convert from pointer to integer constant, conversion loses qualifiers. So I will comment that out. And so if we now invoke the display function, but we pass in the pointer ptr, which is simply a pointer to integer, then of course that will work fine. So if I build around that will work. It will print out 33 and then followed by the other printouts, 47 in the main function as before. So with this, I'm trying to demonstrate that const can be useful in the case we have a function that accepts a pointer to an integer. Again, if you then pass in a pointer to an integer constant, you will get a compile error because the function may attempt to modify whatever that pointer is pointing at. So what you can do is, as we've seen here, we can cast away the const, maybe assign that to a different pointer, and then we can pass in that pointer into the function, which again accepts a pointer to an integer, for example. Instead of a pointer to some type constant, we want to cast away the const so that we can pass in that pointer to that type to the function that accepts a pointer to that type instead of a pointer to a type constant. So again, this is just an example of where const can be useful. In previous lessons, we've discussed the fact that we do not want to modify the state of the object in a const member function, but there is an instance where you can do that using this const cast. So there's a trick that you can do with that. So in this example, I have this entity class, which will be initialized, which has an integer member down here in the private section, and that will be initialized to 0 by default on construction. Then I simply have this toString function, which will print out the member, and then we also have setMember if we want to use that. But for this, we are focused here on the modify member const function. This is void, but it is a const function. So it's going to take in some integer, and we basically want to set the member to that integer, to that argument. But of course, this is constant. We typically do not want to do that. However, we do have a trick here, so we can use this const cast. Now we have to think about what we are doing here. What do we cast from? We cast from this. As I mentioned in previous lectures, we have this pointer, which is essentially going to be a pointer to this entity, which is also going to be a constant pointer to entity constant, because this function is const. If the function is not const, then this is going to be a constant pointer to an entity, as opposed to, again here, this will be a constant pointer to an entity constant. So we want to cast that to a pointer to entity, and that is then going to remove that constant. So instead of having a pointer to entity constant, we are casting to pointer to entity, all right? And then from that, we access the member, and we assign the integer parameter to that. So the argument we will assign to the member in this way. All right, let's look at an example here. Main, I instantiate entity. Firstly, I print out toString. This will give us 0 because of the constructor. And then we do that modify member const function, and we pass in 47, for example, some integer argument. And then we can do entity.toString again. If I build and run, we get 0 and then 47. So as we can see, we have modified the state of the object entity here using a const function, even though that is typically not what you would do. So here, for example, if you try this, if you build now, of course we will get an error. Member cannot be modified because it is being accessed through a const object. That is similar to doing this member, and again we will get errors here. Expression must be a modifiable L value. So if you build, again you will get that error, being accessed through a const object, right? So that is one way. I'll just undo here. So this is one way of removing that const, casting away that const. Of course, I do not recommend this because this goes against what you would typically want to do with const functions. We again do not really want to modify the state of an object when we invoke a const function. Alright, in this example I will use the type ID operator, and then we will do some printouts. So I will include the type info file, and then I have some variables, int x, which I initialize to 47, and then I have a pointer to an integer constant which I named cptr here. I assign the address of x to that. Then I also have a volatile pointer, so I have a pointer to an integer, and that is volatile instead of const, and I also assign the address of x to that. Okay, this is named vptr for volatile pointer. Then I print these types out, so print out x, type id x.name, and then I also print out vptr. Next I'm going to use this pointer ptr as a pointer to an int, and now we can cast away using const cast that volatile qualifier. Okay, so we cast that to a pointer to an int, and then we simply go and print that pointer out, and then we do something else here. We print out cptr. That should give us a pointer to an integer constant, but then I do a constant cast from cptr to pointer to int. Then I print pointer out. Alright, so let's see what we get. Build and run. Types, we get x is an integer. Then we get that vptr, that's a pointer to a integer, okay, but that is volatile. Next we have that pointer, which is now a pointer to an integer. Remember that right here we cast that vptr, we do const cast, so we cast away the volatile. So const cast is going to cast away both const and volatile. So we'll simply get a pointer to an integer, and then we get cptr is a pointer to an integer constant, and then we cast that away, and then we get ptr is now a pointer to an integer. Alright, so this is just to demonstrate that we can cast away both the const and the volatile using the const cast, and then we can also see some additional examples with the type ID operator.